Section 2.5, 2.6, example 8e. Solve n C4 divided by n minus 2 C2 equals 1. To begin, the easiest thing to do is to kind of rewrite this formula by cross multiplying or multiplying both sides by n minus 2 C2. So this is the same as solving the equation nC4 equals n minus 2 C2. Plugging each of those into our combination formula, we have n factorial divided by n minus 4 factorial times 4 factorial equals n minus 2 factorial divided by n minus 2 minus 2 factorial times 2 factorial. This simplifies. 4 factorial is 24. And we can simplify the other side. N minus 2 is n minus 4 factorial times 2 factorial, 2. We can see that n minus 4 factorial on both sides can cancel each other out. We have n factorial divided by 24 equals n minus 2 factorial over 2. We can multiply both sides by 24 to get rid of the denominator. So we have n factorial equals n minus 2 factorial times 12. 24 divided by 2 is 12. We can rewrite n factorial as n times n minus 1 times n minus 2 factorial. Again, n minus 2 factorial on either side can cancel each other out. We have n times n minus 1 equals 12 remaining. To finish solving for n, distribute. N times n is n squared. N times minus 1 is minus n equals 12. We're going to subtract 12 from both sides. And we end up with n squared minus n minus 12 equals 0. We need to finish solving the quadratic equation. We need to factor. We need a sum of negative 1 and a product of negative 12. We can see that 3 and negative 4 will work. 3 plus negative 4 is negative 1. 3 times negative 4 is negative 12. We can then use our zero product property. N plus 3 is 0, or n minus 4 is 0. Solving each equation, we end up with n equals negative 3 and n equals 4. Just like all other examples we've done, we reject the negative, and our solution is n equals